Hello again. This is Math 2270 coming to you from the College of DuPage. And the title of this lecture is an LSA about a simplified pursuit curve. As always, please be an attentive listener while watching these videos. So here's the LSA. An interesting geometric model arises when one tries to determine the path of a pursuer chasing its prey. This path is called a curve of pursuit. These problems were analyzed using methods of calculus long ago, but this is more than 2 centuries after Da Vinci had considered them in general. The simplest problem is to find the curve along which a vessel moves in pursuing another vessel that flees along a straight line, assuming the speeds of the two vessels are constant. Let's assume that vessel A, shown here in the figure, is traveling at speed alpha and is pursuing vessel B, which is shown here, which is traveling at speed beta. In addition, assume that vessel A begins at time t equals 0 at the origin and pursues vessel B, which begins at point 1, 0 and travels up the line x equals 1. After t hours, vessel A is located at the point P equal xy, and vessel B is located at the point Q, 1, beta t. And you see that from the figure. The goal is to describe the locus of points P, that is, find y, the pursuit curve, as a function of x. Okay, so here are some of the questions. I think there are G of them. Question A. Vessel A is pursuing vessel B, so at time t, vessel A must be heading right at vessel B. That's what pursuing means. That is, the tangent line of the curve of pursuit at P must pass through the point Q. And you can look at the figure to see why that is true. Now, for this to be true, yours to show that dy dx is equal to y minus beta t all over x minus 1. Part B. We know the speed at which vessel A is traveling, so we know the distance it travels in time t is alpha t. This distance is also the length of the pursuit curve from 0, 0 to xy. Using the arc length formula from calculus, show that alpha t is equal to the integral from 0 to x of the square root of 1 plus y prime of u whole squared all under the square root du. So first of all, show that. And then, solving for t in equations 1 and 2, you should be able to show that y minus the whole of y minus 1 times dy dx over beta is equal to 1 over alpha. This is the integral from 0 to x. The square root of 1 plus, this is y prime at u, whole squared all under the square root du. Okay, that took us to part B. Then what you should do is differentiate both sides of 3 with respect to x, and so there you're deriving a first order differential equation. X minus 1 whole of that dw dx is equal to minus beta over alpha, the square root of 1 plus y squared, where w is equal to dy dx. Then part D, using separation of variables and the initial condition x equals 0 and w equal dy dx equals 0 when t is equal to 0, show that the solution dy dx, which is equal to w, is 1/2, and this is the whole of 1 minus x to the minus beta over alpha minus the whole of 1 minus x to the beta over alpha. Part E. For alpha bigger than beta, that's an assumption, so the pursuing vessel travels faster than the pursued vessel, use equation 4, the one you just derived, and the initial conditions here to derive the equation of the pursuit. So y is equal to 1/2, that is x minus 1 whole to the 1 plus beta over alpha, all over 1 plus beta over alpha minus, this is 1 minus x whole to the 1 minus beta over alpha all over 1 minus beta over alpha plus, and then the constant here is alpha beta over alpha squared minus beta squared. Part F. Find the location where vessel A intercepts vessel B if alpha is bigger than beta. Finally, part G. Show that if alpha is equal to beta, then the curve of pursuit is given by, it's a different equation, yet a solution is y is equal to 1/2 times 1/2 times 1 minus x whole squared minus 1 minus, and that's all being taken times this 1/2, the natural logarithm of 1 minus x. And then we close with the question of, will vessel A ever reach vessel B? And you are to answer that question and explain your answer. In closing, now more than ever, time is precious. Each day must count. Do the math, it will make you strong. And now more than ever, take care of yourself because self-care is important, and of each other because we're all in this together. Strive to make a difference. God bless you all, and I'll look forward to seeing you in class.